Continuing on with the final exam review, here we have this graph. It says as of May 2009, the U.S. Postal Service adjusted its rates so that mailing a large envelope costs 88 cents for the first ounce and 17 cents for each additional ounce. There is a weight limit for all first-class mail letters and parcels mailed. First class cannot exceed 13 ounces. What type of function is this? This is a step function. You'll notice the graph looks like steps. The second question on this page, when you graph an open dot, then the graph line includes that value. This is a false statement. You could also answer it with the word never. What is the most they'll be charged for any first class piece of mail? Well, it's 88 cents for the first plus 17 cents for the next 12, because the biggest will be is 13 ounces. And that equals 88 cents $2.92. The most you'll ever be charged is $2.92. What about 1.5 ounces? Well, 1.5 operates the same as 2 ounces. Well, it's 88 cents for the first ounce plus 17 cents for the second ounce, which is $1.05. And then the last question, an envelope weighing exactly 9 ounces. That's 88 cents for the first ounce and 17 cents for the next 8 ounces. That's $2.24. Moving on here, we said suppose the number of a business owner's expenses for a product he sells can be represented by the equation y equals 275 sine 0.5 times the quantity x plus 4.09 plus 535. Well, this type of function is a sinusoidal function or cyclical or periodic function. And the length of one cycle, we're looking for the period length. That is equal to 2 times pi divided by b. B is the second number in this equation. So 275 is A, 0.5 is B. So I need to divide 2 pi by 0.5 and you'll get 12.56, which is also equal to 4 pi. Moving on. Here we have a TVM solver. So I'm going to take the calculator and show you how to input this information for the TVM solver. If you'll notice, there is several questions. This is very repetitive, so I'm only going to do 4 or 5 and then move on to the next page. Alright, so for the TVM solver, the finance solver, here we have Sam wants to save money for the next 10 years. So in N we put 10. He would like to have $20,000 by the time his investment matures. If he invests in an account with 2.7% interest compounded monthly, how much would he need to invest today? Well, so here we need to solve for present value. And then in N, in our finance solver, we have 10 times compounded monthly, so 10 times 12. Interest is 2.7. Present value is unknown. Payment does not exist. 20,000 is the future value, and 12 is the payments per year or the compound periods per year. Go down to PV and hit enter. You get $15,272.22. Julio's brother Jesus wants to save for retirement. Jesus believes that he will need $500,000 since he plans to be retired for 15 to 20 years. If he starts with $3,500 and finds an investment account earning 3.5% interest compounded annually, how many years would he need to save? All right, so that means we're trying to find N. We're trying to find N and then figure out years. Well, in this case, N equals years because the interest is compounded annually. So we don't know n. That's what we're trying to find. Interest is 3.5. Present value is negative 3,500. Future value is 500,000. And the payments compound periods per year is 1. N gives us 144.23 years, but it's going to take 145 years to actually get there. Next one, we'll do 2 more. Johnny wants to save for retirement, and he has $5,000. If his savings account earns 7.5 interest, how much will he have in 20 years? Here we're trying to find future value. It's compounded annually, so that means N is number of years. So 20 years, 20 times 1. Interest is 7.5. He starts with $5,000. And make sure you PY and CPY on 1. Go down to future value, hit enter. You get $21,239.26. All right, this last question that we're going to go over on this page. Coach Buchanan was offered $20,000 for an account worth $75,000 with monthly compounded 6.3% interest maturing in 23 years. Should Coach Buchanan take the offer or keep his investment? Well, so what we need to see is $20,000 better now than what this $75,000 in 23 years is worth now? So we need to find the present value of this account and then explain whether or not we should take this offer. So in 23 years times monthly compounded interest, 6.3 is the interest percentage. We don't know the present value, payment 0, but we do know it's worth $75,000 in the future. PPY and CPY are 12, and I get $17,677.25. So if you're looking at this $75,000 account 23 years later is right now worth $17,677. Should I take $20,000 for this account? The answer is yes. I should accept the offer because I can reinvest $20,000 and end up with more than $75,000 in 23 years. All right, so here we're trying to look at what is a Hamiltonian and an Euler circuit. Hamiltonian must pass through each vertex exactly once and end where you begin. An Euler circuit must pass through each edge exactly once and end where you begin. So I'll make this font a little bigger so you can see it. All right, so which of the following is both? Well, you should remember that an Euler circuit has all even degree vertices. An Euler circuit has all even degree vertices. So if we look at these graphs here, we see that this vertex has a degree of 4, this has a degree of 4, 4, 4, 4, 4. So this is an Euler circuit, so A is a possibility. This has 4, 4, 2, 2, and 2. So this is a possibility. If you look here on graph C, this vertex right here in the top middle only has a degree of 3. So it's an odd degree, which means it's not an Euler circuit. D, if you look at these here in the middle, this has 3 edges coming off of this vertex, which means this has a degree of 3 here in the middle. This has a degree of 3 as well. Therefore, D is not an Euler circuit, nor can it be both Hamiltonian and Euler. Hamiltonian means you have to go through each vertex exactly once, which means you don't have to use every edge. Well, if you try to go through this one, if you start at this vertex right here, we can go up, back down to the middle, and then all the way through, and then back around. So this is a Hamiltonian and an Euler circuit. This is not, because once you go to these 2 points, you come back to them. So this is not a Hamiltonian. Hamiltonian circuits or paths use the vertices, or the vertex, plural. Each Euler circuits use the edges exactly once. Another way to say you're trying to find an Euler circuit is to traverse the graph with no backtracking. The minimum possible solution to a weighted graph. Now we have numbers on the graph. Weighted graphs look like this right here. The minimum possible solution to a weighted graph is the product of all the numbers. Well, product here should actually say sum, because product means to multiply all the numbers. Sum means to add. So this is false. It should be sum of all numbers. An Euler circuit is always a Hamiltonian. Well, we just found out here on B, this is an Euler circuit, but it's not a Hamiltonian. So that's false. If you look here, this picture right here, graph C, this graph is a Hamiltonian. I start at this vertex here, go across, down, and then back to this vertex here. This is a Hamiltonian, but it is not an Euler, so this is a false statement as well. The first step to solving a weighted graph is finding the odd number vertices. Because in order to solve the weighted graph, we must find the odd vertices, and turn them into an even degree. So right here, whenever we have this weighted graph, what we want to do is solve this weighted graph in terms of the number of hours or the total number it takes to solve this graph. So the first step is to find the odd degree vertices. Well, the only 2 odd degree vertices, you can double check, but it's right here, this one right here, and there always will be a pair. There will always be at least 2. So if you find 1, you'll find a second. If you find a third, you will find a fourth. So this one and this one right here are both odd. Well, we have to then copy the path that's the shortest between these 2, and we can go here to here, but that's 4. We can go here to here, but that's 6, or we can just go right back up here, and that's 2. And then if you add all these numbers plus an additional 2 because of this path that has to be duplicated, you'll end up with an answer of 67 for this weighted graph. You look at this next question, which properly minimizes the network. This is where we're trying to eliminate all cycles. Cycles are enclosed figures. They look like oblique polygons in some way, or circles and loops. So A still has this loop right here. B has 3 loops or more. D has this loop right here in the middle, so C properly minimizes the network. The most efficient network of this graph, we're trying to do this same concept right here, except with numbers. So we need to take the smallest numbers of this graph and try to minimize the network most efficiently. So we start with 2, 2, 3, 2, 3. We're going to start with those, and notice we did not create any loops. But then we need to take this 4, this 5, and I believe that's it, which gives us an answer of 21. The most number of colors needed to color this map here